Thank you very much, and welcome everybody to this talk. Okay, so I'm going to be speaking about one of our projects that is focused on making food-grade recycled polypropylene. And the reason it links up to sorting is the need to separate food from non-food. Our project, called Nextloop, has 50+ members involved in it across the supply chain, and we are involved with the recycling of polypropylene. And of course, polypropylene comes in the format of pots, tubs and trays, and sometimes bottles. And it's as big a packaging plastic as PET, but only recycled at about 1/4 of the rate of PET in Europe. And in the USA, it's only recycled at 8%. So it's barely on the indicator. When we make plastics for food-grade applications from recycled materials, we must have food packaging as the input. So both US FDA and EFSA demand that we only use food packaging. And of course, when we collect post-consumer plastics, we have both food and non-food. So how do we separate the two? And this is the question that we've been looking at for some time. So in the very first step, we have to separate the polypropylene. The second step is separating food from non-food. And the third step is to decontaminate the materials. Sorting on its own is not enough. We need all three steps in order to make a food-grade recycled material. And this is really what food-grade recycled polypropylene looks like. This is real post-consumer packaging. We have to take this material and turn it to food grade. And I'll just go through some of the steps that we're working on. One of my big things is for packaging is we use too much color and pigment in packaging. If we really want to recycle for food packaging, we would make them natural or white. All the other applications should be colored, like pastel colors for non-food, and toxic materials in black. Then we'd have a really simple task of separating and recycling. So for many years, we worked on specialized techniques to separate food from non-food. And we used fluorescent markers for about 6 years, developing a very good technology to separate food from non-food. And there are other techniques like digital watermarks, digital marks on packaging with a thing called curve code by Filigrade. And this was our technology using fluorescent markers called polyprism. They're the two technologies we had. Polyprism for fluorescent markers, and then the decontamination technology was pristine. This is how our markers worked. If you design a label and print on it with the fluorescent ink, it looks invisible, you see nothing, but under ultraviolet light, you see a change in color. And then you use the change in color for sorting. And so I'm going to show you a trial we did with fluorescent markers, so you can see how this is actually happening in real life. The packaging has labels on it with fluorescent markers, and it's being viewed under ultraviolet light at full speed. And this is where the ultraviolet light line is, scanning the packaging. And as each package goes under the UV light, it changes color. We detect the color, we eject it. This system is very accurate. First pass, sorry, we go back. Oh, sorry, I'll go forward. On first pass, we're getting 99% plus separation of food from non-food. Very high yields. However, when you think about this, you have to put a label on a package. You have to alter the package in some way. And some packages do not use labels. So where you have labels, it's okay, but you have a cost, and then you need separation. So we've been working in parallel with using artificial intelligence or deep learning to separate food from non-food. And so now we're working with one of our technology participants, Tomra, using their GainNext system for our separation. We're still using our decontamination technology for this. Now, what this does is, as materials are being examined under a belt, we're actually looking at all of the packaging, and each package is looked at, and it can be classified. But before we can do this, we have to teach the machine what is food, we have to teach it what is non-food, and we have to do this many, many times with many objects. So we've spent a lot of time teaching the machine. The machine is basically like a brain that can remember things, but we have to teach it over and over again to make sure it doesn't make mistakes. Now, in this system, we're using both GainNext and AutoSort. So we have near-infrared, visible, and AI together. Now, the advantage of this is when you have bottles that all look the same. For example, these bottles may all look, this happens to be PET with sleeves. Some of them may have PVC sleeves. And of course, if you're using just AI, you just see the shape. But with infrared, you also see the polymer. So this is a much more powerful technique. It's a cross-check on the composition. So here is the system working with mixed polypropylene packaging. This is being run at 5 tons per hour on a wide belt, and we're using both NIR and GainNext for AI. Our target is to get 95% food packaging in the resulting material. And you'll see at the moment we have tuned the system to select white, natural, food grade, and eject colored and non-food grade. So you'll see here, the first one is the ejection side. This is what we're ejecting. This is all useful polypropylene, which we will convert as well, but we're separating the non-food products here. And the accept side, this is all the food grade packaging. Some green, one green, but the rest is basically natural and white. And we were getting greater than 97% separation. This is enough to go forward to food grade recycling. So we can go further. We can separate packaging based on, for example, based on shape. So in this case, we're separating trays and bottles on the left-hand side and the other materials on the right-hand side. So if you teach your system very well, you can then play a formula on what you're separating. So not just polypropylene and food grade, but also trays, bottles, tubs, and so on. So there's more to be done in this area. This has a big implication for designers of packaging. So when we started to work with AI, we realized these ribs are something that the AI system gets into its brain. When it sees ribs in a package, it says, that's probably a food grade tray. And so when you're designing trays, you have to build in features that the AI system can actually recognize. And of course, we have here on this side a butter dish, and this is a non-food bottle. This is polypropylene. And of course, this has to be recognized as non-food. Now, once we teach the system how to separate packaging, it's important product designers don't change their shapes too radically, because then it'll get confused. And I'll give you one example of this. So for example, when we were separating packaging, this is an ice cream container. It looks white and big and rectangular. Here's 2 detergent boxes. They're both colorful and they look rectangular as well. But here is a white detergent box. So the white ice cream container and detergent box could get confused. So it's really important for product designers to start to understand there will be rules for AI sorting, which they have to try and follow in the future. So we need to actually go all the way back to the beginning to make sure that we're not creating a problem later on. So that's the end of my talk. I only have a few minutes, so I'll pass on to the next speaker.
I think your comments on the design were really interesting, and how designers need to incorporate this. And obviously, that's going to be part of the new PPWR, is looking at design for sustainability. Could that be incorporated in those rules? And how do you get brands, and obviously Personal likes to use white, so how do you get brands to change their mindset so they're thinking about the next step?
There's one simple way of solving the issue. in a big brand owner, the designers report to marketing,
Yeah.
right? What we need to have is marketing reporting to sustainability,
Yeah.
right? When sustainability people make the choices, they'll say, sorry, you can't use colourful, you can't use pink in those packages, you've got to use natural white or others, because at the moment we're all thinking about the market and not thinking about recyclability. And in the future, we have to have recycling for the circular economy. In other words, your package has to go back to the original package or something similar. So we really need to change the mindset of management, and then marketing will have a different set of rules. At the moment, they don't have rules. So that's the big thing. Technically, we can do all those things. Recycling is straightforward, but the marketing people give recyclers problems every day. They lose yield and so on. So if we're really serious about the circular economy, we have to change some big fundamentals.
Could that be through regulations and legislation? Your original proposition there about having different colours for different types of products, if that was legislated, presumably that would solve...
It's on the edge, because by 2030, all packages have to be recyclable.
Yeah.
So if someone says, well, a pigment or print on a package makes it unrecyclable, then maybe it will be forced. But I have a feeling it'll be soft at the beginning, and it'll take more time before we push the regulations up. I think we have to teach the industry to walk first before we run.